Hi, in this video we're going to find the length of an arc of a circle when we've got a right angle triangle involved. Now we're trying to find the length of the arc ABC. So it's this arc that goes through A, B and C like that. Now in order to find the length of an arc, we need this angle here at the centre of the circle. And to find that angle, well, we could find these two angles here and then just subtract that from 360 because the total angle around this point is 360 to find that one. So basically, we probably want to find, say, this angle here. Now, this line here, AD, is a tangent to the circle. It says D and DC are tangent to the circle, and that is a line that touches the circle. So it kind of bounces off the circle like this. So this is a tangent. And the line from here, and the line here is the radius, because it's the line from the centre of the circle to the circumference. And although you might not have covered something called circle theorems before, there's one circle theorem we need to use here, which is that the angle between a radius and tangent at the same point is 90 degrees. So this angle here is 90. It looks like it's 90, and it is 90 because it's the angle between the radius and the tangent. Similarly, this angle here is also between a radius and a tangent, so that's going to be 90. And another circle theorem that's relevant here is that the tangents from a point to a circle, so from the point D, the tangent to this point here and this point here, they're the same length. So this length here is the same as this length here. So we can mark those as equal. So that means this is also 21.9. And that means these two triangles are exactly the same. They're congruent, we say. So whatever that blue angle is here, we got the same angle here. So we can just double that angle. So how do we find this angle here? Well, let's concentrate on just this triangle here. If we just draw it separately, we've got the right angle here, and then we've got the 12 here, and we've got the 21.9. And we're trying to find this angle here. So this is the purple triangle. Now, we don't know what this angle is here, so let's just call it theta. Theta is a Greek letter we often use for unknown angles. And remember what we do now, we label these sides here with known lengths relative to this angle of interest here. So this side is opposite that angle, so we call it the opposite. I put an O in a circle. And this side here, that's adjacent to, next to this angle, so we label with A for adjacent. So we covered this in a previous video. And then remember, we use SOHCAHTOA to work out what trigonometric ratio we're going to use. So we can see we've got O and A here. We've got the O and the A, so it's going to be this one here with the O and the A. So that is short for tan of theta. T is short for tan. So tan of the angle of interest, theta, is equal to O over A. And if that doesn't seem familiar to you, please watch my videos on that first. So let's just substitute everything in. We got tan of the theta is O, which is 21.9, over A, which is 12. And then to get rid of that tan in front of the theta, we do inverse tan of both sides. So tan to the -1, it's written as. So the inverse tan cancels out the tan, and then we still got to do inverse tan of the right-hand side. So we do shift tan, or your calculator might be different, to get the inverse tan, 21.9 over 12. And that gives you 61 let's do a few decimal places, 28 degrees. Okay, great. So this is 61.28 here. Now, as we said, this triangle below is the same, so we get 61.28. And now, because we know the total angle around this point O is 360 degrees, we can just do 360 minus the 61.28 and minus another 61.28. There's two lots of it. And that gives you 237.44 degrees. So this angle here is 237.44 degrees. Now we want to find this arc length, this length here. Now remember how we do that? What we do is we find the perimeter of a full circle, so the length of the full circle, and then we've got to find the appropriate fraction of it, don't we? And what fraction of a full circle do we have? Well, we've got 237 3/60ths of a full circle. So let's do that to find the arc length. The arc length is going to be the appropriate fraction of the perimeter of a full circle. So 237.44 3/60ths of a full circle. And then you do that fraction of the total circumference of a circle, a full circle. So that's 2 pi r, isn't it? So 2 times pi times r, the radius. And what's the radius here? It's 12. So it's 12. And I just need to calculate all of that. So 237.44 over 360 times by 2 times pi times r, which is 49.7 centimetres. And that is the final answer.